fraction. So I'm going to have to figure out how to make that a fraction. Well, this is that trick with radicals. Do you remember when you did limits with radicals before? You multiplied by the conjugate? And you will get a fraction. Because if you substitute in infinity right now, you're going to get infinity minus infinity. It might be 0, I don't know. Okay, so I'm going to get the limit as x goes to infinity. What's going to happen when I multiply those out? X squared plus x what? Minus x squared. Okay, you guys should be doing it with me. Because it's going to be on your test all over this. Now, before you do L'Hopital's rule, you better simplify and see if you can get an answer. You may not even need L'Hopital's rule. That's the last thing you do. How about this one? We're not going to look at answers. What are you going to do in college? You don't get any answers. Well, he won't do it anyway, so what's the difference? Okay, what happens here to the x squared? So I get x over this. I know. Do the x's cancel? Well, I get infinity over infinity. How about, do you want to use L'Hopital's rule? I don't like to really take a derivative there. I can think of a better way to do it. Yes. Well, how about this? An answer key is not always the best way to do it. Isn't this the same as this? Plus 1 over x. Okay, Eric, is that the same? Because what happens to x squared? Why would I do that? Because then let's follow through on my thinking here. This is x. What's the square root of this? Eric, we're doing the problem. Why do you have to look it up? This is 4, 5. This is what's due for today. It doesn't matter. 4, 5 doesn't have anything to do with that. What is this? Isn't that the same as this? And isn't the square root of x squared x? Over x, square root of 1 plus 1 over x plus x. What's going to happen to the x's? The x's will cancel out if you factor them. So I'm going to get a 1, and I'm still going to get this. I'm going to get 1 over the square root of 1 plus 1 over x plus 1. That's not 0. Eric, what is this? It's 1 over, because if I, let me show the work. I'm going to factor out the x in the denominator. Then you may cancel. What's going to happen to 1 over x? It's going to go to what? 0. Hey, guys, did you get this? Yeah, you do the work with me. No problem. Copying the work isn't doing your work. So that's not the same thing. Anyway. Okay, another. Now, could you use L'Hopital's rule? Yeah, I suppose you could, because the derivative of this is going to be 1. The derivative of this is going to be 1 half x squared plus x to the negative 1 half times 2x plus 1 plus 1. I don't know. That didn't seem that much easier, but if it is, that seems harder to me. I can do it that way if you want me to finish doing it that way. I like the other way better. Let's do another one. Katie and Eric, you're supposed to be in this place. You're supposed to be there. What's another one you had a question on? 41. Eric, how am I going to do this? I know, so you should be doing it right now since we're doing it. You haven't tried anything. Let me see your paper. Well, I don't think you have anything written. Okay, you guys, this is that function to an exponent. So it's not even, it could be e, it's probably going to be e. So why don't we do this? Well, why is it's not going to be exactly e. If you let that go to x go to 0, this is going to become infinity. This is not 1. It's close to 1. So let's log both sides. This is how we did this. This is the trick, and you won't be able to get it right on the test if you don't know how to do it. So copying homework isn't going to do you any good. So this is 1 over x times the log of 1 minus 2x. Right? This is how we do these. We do logarithms. And it's how you do the derivative of x to the x as well. It's the same kind of thinking. Hey, David, what do I do next? Oh, sorry. I just took this 1 over x and put it in front. So I have to use L'Hopital's rule. I want to take the limit as x goes to what? Was 0, right? Was it 0 or infinity? Okay. Of the log of y. Well, guess what the left side is? It's the log of y. Now, I'm going to rewrite this a little bit differently because we're in L'Hopital's section, so my guess is I'm going to probably use L'Hopital's rule. So I have to have a fraction. Is that okay? What is the left-hand limit? Just the log of y. There's no x. Okay, now what am I going to do here? If I put in 0, what do I get? I get the log of 1 over 0, which is negative infinity over 0. Oh, I can. It's still indeterminate. Anytime it's indeterminate, I can. Yep. Infinity over infinity, 0 over 0. Any one of those 7 indeterminate forms, L'Hopital's rule probably applies. So let's do L'Hopital's on the right-hand side. What's the derivative of the log of 1 minus 2x? Yeah, 1 over 1 minus 2x times what? Negative 2 over 1. Oh, yeah, you're right. I'm awake. Not really. I was thinking of log of 0. Yeah, you're right. So I do have a, so it's still going to be, sorry. This is log of 1, which is 0 over 0. Now I'm happier. You're happier. Okay, what does this give us? Simplify that. Can you take the limit of this as x goes to 0? Don't do L'Hopital's rule again unless it applies. What's that going to give you? Eric, what's that give you? When x is 0, this is going to go away. So it's negative 2 over 1. How do you solve that? E to the negative 2 equals 5. Either way. I like 1 over e squared better, actually. See, now you'd have 2 problems done from this assignment. But you can copy the answer key at home. That's okay, I guess. You're not going to learn anything. Are there other ones you want to look at? Number 19 looks just like one I've seen on the AP exam. It would be a multiple choice question, I believe. I think you've seen it, actually. And actually, this one can be done 2 different ways. You could use a Taylor series. What's that? You could use a Taylor series. You don't have to. Oh, it's It's never going away because you can't get a 5 without it. But do you want to just use L'Hopital? Does L'Hopital apply? Do you want to do it both ways? That's 0 over 0. Well, first let's do L'Hopital's rule because it does apply. And no matter how I do the problem, it's got to come out the same way. So it's e to the x minus 1 over 2x. Substitute 0 in, I still get what? 0 over 0. So it's the limit as x goes to 0 of e to the x over 2. So that's e to the 0 over 2, which is 1/2. It's actually easier to do the problem than it is to copy it. Do you want to do the, do you guys remember the Taylor series for e to the x? It's e to the x minus 1 minus x over x squared. Okay? What's e to the x? Plus x. I don't know why you struggle with this because it's not that bad. Eric, how do you do this? So in place of e to the x, you do what? 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Very good. X to the n over n factorial minus 1 minus x. This has been a free response kind of question. Well, it's not that bad. What cancels? The 1 goes, the x's go, and then you divide x squared into each one of these. Oh, that's not hard. What do you do with exponents? Subtract them. So this is going to be 1 over 2 factorial plus x over 3 factorial plus x to the second over 4 factorial, x to the n minus 2 over n factorial, and x is going to go to 0. So what's going to happen? It doesn't matter, but if it's on the free response, you might have to do it that way. You've seen free responses like that. Are there other ones you want to look at? Alex, are there other ones you want to look at? Well, then you should be doing math. Well, 4 or 5 should be in today. Other questions?